This is the BBC Bridge Companion game console. It takes cartridges and they just slot in the back. I did a video of it either late last year or early this year, actually in operation as the physical console. But as it's got a Z80 processor inside and the Texas Instrument display processor, uh, and I've just emulated the Texas Instrument display processor on my emulation software, I thought, well, I might as well just add it to my emulation sets of computers. So I've done that, and in this video I'll show you actually in operation on my emulator, and then go through the source code of how easy it was to get up and running. So this is the emulator as it stands at the minute. So I've put a little menu at the front of it so that I can select whichever computer I'm emulating and run that. So these 6502 computers, the 6502, I just added the emulation for that. I'll go for that in my next video. But this video is about the BBC Bridge Companion, which is a Z80 processor. So if I select that, it comes up with the screen saying I haven't got a cartridge selected. So if I go into my emulator menu and select on the cartridges, and then I can just press P to, well, I can press up and down arrow to select which thing I want, and then press P actually start, and P again. So this is just going through like a training bridge game, and you can select the club card by pressing C, or H for hearts, D for diamonds. So if I play a card and it suggests playing this card because it's just doing the training game, and again I can just press P to play and go through like a hand of the game. Or I can select another cartridge at any time, and it will then go into that cartridge and start that up. So if I now go through the source code, so there's 3 files to go through in the source code. The first is a configuration file. This is the same as you'd see for any other of my emulations. It just defines the thing specific for this particular console. And one thing to point out is that the actual processor, the Z80 processor on this console, is only running at 0.5 megahertz, so 500 kilohertz. And the reason for that is they take the clock from the video processor. So the video processor has an input clock of around 10 megahertz, I think, and then that divides it down, and then on one of the pins of the actual video processor, the Texas Instrument chip, it actually has an output which is divided down, and it comes out at about 0.5 megahertz. And in the actual documentation for the chip itself, it actually says that that chip is rarely used. It's not used much, but on this console, I guess they've saved the crystal by just taking the divided down version of the input clock frequency, because the Z80 couldn't run at whatever the actual clock on the actual Texas Instrument chip is. So they take the divided down value of that. And then it defines like things about the display resolution and items like that. And there's not much really in it apart from the keyboard matrix. It has a keyboard matrix a bit like the ZX80 and ZX81 Spectrum and other standard kind of computers, which just run off of a basic matrix which reads off of data lines or address lines. And so this one's very simple. It's just a few keys on there, and they are converted from something like the up cursor key converts to this keyboard scan code, and for example C for pressing club button converts to that scan code. So that's all there is in the configuration file. So then I'll go for the header file for the emulator. At the top, so I've added something new to my emulators where I can actually define a message which comes up on the screen when you actually enter a particular emulator. In this case, it just shows you what the keys are defined for the console, because it's not a QWERTY keyboard, so it doesn't just naturally map to what a computer would normally map to. So I've got the definitions here, so when you go into it, you can see what the keys are. Normally I would just put like little notes as to what I haven't completed on a particular emulator, just to remind me. and if that message isn't defined, then no message will pop up at all. Then I've got definitions of the ports allocated on the actual console itself. So it's got a Z80PIO, it's got port A and B on the Z80PIO chip, and then it's got the text instrument display chip and what ports they're mapped onto on the Z80 processor. I say where it's going to put the memory for the Texas Instrument display chip, so I put that above the Z80 memory so the Z80 can't accidentally write over it at all. Then internally in the actual console itself, it seems to have a configuration where it can actually do memory paging, but it actually doesn't make use of that at all. So it's kind of, I don't know if they had future plans for it or they just designed it in a very generic way so that they could release other stuff in the future. I don't know, but as it's only got a 500 kilohertz clock, it wasn't really going to play any arcade games of such. Although if they'd have made the clock faster, it could have done. It's just that it doesn't have a sound chip, so it would have been a silent console in that kind of respect. And I've just got prototypes for my functions. And then this is the C code for the actual emulator itself. At the top, it's got global variables brought in from other modules. This one so it can get things like key values from key presses, and it knows where snapshot files are when they've been selected in the snapshot selection menu, and then Z80 related global variables. Then at the very top I've got this is the entry point for if you compile it as a single executable, and this is the entry point if you compile it, if you're going to use it within, say, a microcontroller where you've got other programs running, and this can be like an entry point from a menu like you saw the multiple menu at the start of this video, and the single entry point just calls the multiple entry point area. And so in here it just initializes the display. So in this case it's a Linux display driver. It initializes Z80 and then it initializes a video processor. And this is a memory map for the actual console itself, and it's a static memory map. Although the console can actually do paging, it only actually does static placement of memory, so that you don't have to worry about things swapping around. And at the top here, this is the Texas Instrument video memory at the very top. It loads the BIOS for the console here, which puts up the message saying you haven't got a cartridge installed. So that's all that BIOS does. And then what I do is I memory protect everything apart from where there's actually RAM in memory, which prevents any programs from overwriting themselves. Because on the ZX81, it does overwrite. If you don't have write protected ROMs, then it'll overwrite itself in certain locations. So that's just, I don't think it does it on other consoles, but it might do on some consoles. So this is if I put I can automatically load a cartridge at the start, which I don't do in the case of this emulator. And then I set up the callbacks for certain things. So this is for setting up a reset callback and the clock callback for the Z80 processor. So the two callbacks I do from the CPU itself. And then the PIO callbacks I set up here. And then the display callback for the Texas Instrument chip I do here. And then we go into the actual emulation itself. So this is where it displays a message if a message has been defined. Then it just makes sure that the display has been refreshed before it starts the execution of the actual console code on the Z80 processor emulation. And then when it comes out of that, it just cleans up anything before it exits the program. So this is the first of the Z80 callbacks, which is the reset. So if a reset occurs on the Z80 processor, it will then in here reset the Texas Instrument display processor. And this is a callback for one of the PIO ports, I believe, and it's about does what seems to be memory paging. So this is the way it does the memory paging, but I haven't actually included this code because it wasn't actually required, even though the hardware seems to do this kind of thing. As you can see, it can actually hold up to I think about 192k of memory in its cartridges. But yeah, this is all just commented out because it doesn't actually, I didn't need to do this, even though I looked into how it actually operated. This is the keypad callback, and so this just does a scan of, or it looks up what the scan code is from a key press. So you go get a key press on the Linux keyboard, say a C button, and then with that C button, it looks up what the scan code is and then returns that to the Z80 processor. So the Z80 processor knows what key's been pressed. And then this is the last callback, which is for the Z80 processor, and it's for every clock period. And the Texas Instrument display processor on this particular console does a maskable interrupt, which is like an RST38 Z80 instruction, and it just calls address 38 in the Z80 memory map, and that's what it does for this particular. So that's maskable for this console, but on the ColecoVision console, where you saw the first appearance of this in my emulation, it does a non-maskable interrupt. So the Texas Instrument display chip can be configured in multiple different ways depending on which system you're on. Then for every frame, checks if the Texas Instrument interrupt is enabled, and it sets a period after the frame. So this is like a vertical sync, which triggers the interrupt, so that it'll wait for the period that it would take to update the display and then produce the interrupt. And this is where I can select a game cartridge, and if one's been selected, then it does a reset of the Z80 processor and starts execution of that cartridge. Here I just check for any other key presses. So I think in here is really I just check for a breakpoint when I'm doing in debug mode. So I can breakpoint into my actual Z80 code and actually step through the Z80 code. But that's not normally used in normal operation. And this is where it tells the Texas Instrument display processor to update a display frame. And that's all the code